Hello everyone. In this class, we will discuss about the signal flow graph. As we have already discussed the basic of the signal flow graph. That means signal flow graph is nothing but one of the alternate method of block diagram reduction technique to get the transfer function of any complex system. So in case of block diagram reduction technique, what happens? See, there are different blocks which are interconnected either in parallel series. There are several number of summing blocks, several number of take up points and all these things. So what happens in case of block diagram reduction? There may be some there actually that procedure was tedious and time consuming, and there may be some problem in getting the reduced block diagram in some complex system also. One of the best method in this domain is known as the signal flow graph. So signal flow graph, by these three terms, signal flow and graph, you see the graph. In the circuit theory, basic knowledge of the circuit theory, you must be aware of this term graph. That means there will be some path, branch, node, input node, output node, outgoing path, forward path, backward path, and all these things. The concept will be used here. And signal flow means the signal is actually originating from the source and passing through defined blocks to go to the output side, such that we can get the output by input, that means the C by R, right? So actually basic definition of the signal flow is graph is that actually to represent the system we can use the several number of algebraic equations, and once the several number of algebraic equations are given, that means there are certain coefficients of it, and that means the set of variables are there, and this relationship between this set of variables of algebraic equations are described by some graphic by graph, the graphical representation or of the relationship between the set of variables of defined algebraic equations is known as the signal flow graph, right? So actually if I take the example of set of linear algebraic equations, then it will be bit clear to you what actually I want to mean. So here you can see the set of linear algebraic equations. This is one equation, this is one equation, this is another equation, this is another equation. That means there are four set of algebraic equations, and four set of algebraic equations having the different variables which are actually related by algebraic equations. Now by this signal flow graph, what you have to do, we have to get how this x1, x3, x4, x5, x2 and all these variables are related, and this relationship is expressed as a whole is in a pictorial form. That pictorial form is your actually signal flow graph, and definitely there you have to mention which one is your input variable and what is your output variable, and we are considering x1 is your input variable and x5 is your output variable, right? And intermediate variables are there. So whenever you consider construct the signal flow graph, first of all we have to keep in mind the concept of graph. That means there will be node, and all these variables will be your node. How many variables will be there? I can write here, say this is your I can write here, this is your x1, this is one node, right? And I can use separate color, you understand? So this is x1, and you see there is a variable x2 and variable x3, variable x4 and variable x5, right? So these are the five variables, and each of the variable is treated as one node, right? I can take it, tell it as the node, and this is your input node, this is your output node. And in this analysis we will try to give the definitions what I am talking about. That means first of all, this is your input node. Input node means there will be only the outgoing branches. Outgoing branches means what do you mean by branch? Say for example, anyway, first of all we will construct the signal flow graph and then we will define these stuffs, fine. So first you see this equation, say I can say these equations, this x2. What you have to do, you have to take this x2, means this node. This node is constructed with a1 to x2, sorry, a1 to x1 first of all. So this is related with x1 by some path having gain a12, and this 1 2, see, ij, this is the ij notation. This 1 2 3 2 4 2 5 2 2 3 3 4 4 4 3 5 4 5, and these are the coefficients which are denoted like aij. See, aij means from ith path, ith node to jth node, right? So you can see this ith node to jth node, that means the direction of the signal flowing can be obtained by this notation. So a12, 12 means from node 1 to node 2. So we can write this is straight line and giving an arrow such that it can be identified the signal is passing from x1 to x2, and this is a branch or a path, right? This is a path, this is a simple path or a branch. Branch means if we consider the total path from x1 to x5, so this is a branch of it. And this is, once the concept of branch is incorporated, this must have a gain that is known as the branch gain. And what is this branch gain? A1 2, right? So this, only this part, but you see this signal is going from there to there, that means x2 will be your output node and x1 is your input node, and x2 is denoted by x1 into a12. As simple as that, the concept of you see block diagram. What is that? That means R, this is your G, this is your C. So what we get? C is equal to R into G, right? So if this structure in the block diagram can be expressed like signal flow graph, how can you write? This R will be one node, input node, this C will be another node, and there is a path, that is branch from R to C, and this path branch having gain G. So this is way how the block diagram is again can be written like signal flow graph. And major advantage is that once the signal flow graph you can construct for any block diagrams given, so from that you can easily find out the C by R, that is the transfer function of the system, right? So we will consider these sections coming back to the problem, right? So similarly, we can just write down all the equations. Like x2 is again a3 to x3. a3 to x3 means x2 and x3 are related by path a3 to, and 3 to means signal is coming from 3 to 2, node 3 to 2. And as this straight line we are considering such that if possible the signal may be going from x1 to x2 to x3 to x4 to x5 in a single direction. So we will consider this path as like this, right? Because we are considering the signal is coming from 3 to 2, right? So a3 2 is the branch gain, and this is directed in opposite way. That is why we have just not used this path. Maybe it can be used later on, right? Next path is that a4 to x4. a4 to x4 is same thing, where you see from 4 to 2 signal is coming. This is a42, right? Next a52. a52 is the block where you see this signal from 5 to 2 is another path, again a52, right? Next the equation number 2. Here you see x3 is equal to a23 x2. a23 x2, that means from 2 to 3 you will be having a direct connections, right? From signal x2 node to x3 node signal is flowing, and its gain is given by a23. 23 means from 2 to 3, right? Similar to this a4 x4, x4 node, that means a34 x3. So 34 x3 means 3 to 4, that is a straight line direction, we can say it, and gain is a34, right? And another plus is A44X4. A44X4 means from 4 to 4. That means the structure is like this. That means it originates from here and it terminates at here with gain A44. And this kind of loop is known as one's self loop. So that will I will describe. Next part is X5. So X5 equations, that is A35. That means the signal is generating from node 3. So you can use this A35. We are trying to avoid the path such that in future we can have some uh, easier solution to get the output by input. And another is a 45x4. 45x4 means the signal is going from 4 to 5 with gain a 4 5, right? So this gain can be 1 2 3 4 5 6 7 8 -1 -2 whatever, right? So different gains we are getting. So ultimately you see what this is your input and this is your output. So you can add another node there which gain of 1 such that this is such shifted positions. We can have a number of node there with gain 1, right? So x5 is x5 same node as the gain is taking 1. Already we have discussed this during the discussion of the transfer functions. Now this is your x1 and x5. So this is the way how now see, these are the four equations we have written. That these are the algebraic equations, and all these equations, the variables, that means x1, x2, x3, x4, x5 and x6 and all these things, these are all calculated, that means represented by some graphical representation, and all the variables are interconnected here, and finally c by r will be equal to actually your x5 by x1, that we have to calculate. And that gain calculated with the help of that is known as Mason's gain formula, right? Well, now I am going to discuss about the Mason's gain formula and how this Mason gain formula can be used to find out the gain of this overall signal flow graph, right? So here we will discuss about the Mason's gain formula. So Mason's gain formula is that which is usually used to find out the gain of any system whose signal flow graph is given to you like this. So this is a kind of signal flow graph given to you. From there you have to find out the actually the gain of the system, that means output by input, which is nothing but the transfer function. So Mason gain formula is written like T. This is the gain equal to 1 by delta, that is the standard form, pk delta k, right? So this is the Gaussian formula, that is T. Here in this case this T is nothing but x5 by x1, right? So delta pk and delta k, this is summation range k. That means the variation of the k will give you the variation of the p and delta, and ultimately this is the formula by which you can get the signal flow, that is the overall gain of any system, right? So what are these parameters? Actually, first of all, you have to know the parameters k. K is known as forward path number, that is the number of forward path, which is very important. uh, Actually this system I am not going to analyze. I will take some other systems to analyze. This can be analyzed also, but this picture is given here or taken here to make you some understanding of the different terms or the different terminologies normally used to describe the signal flow graph. So first of all, k is denoted as the kth forward number of forward path. So let me explain the term forward path. Okay, and already I have discussed the two sections. I will just take the example. First of all, we will take it just a bit different thing. Input node. Input node is this is input node, and see, input node is defined as the node which is having only the outgoing branches, and in C this is having the outgoing branches. This is no incoming branches, but this is the branch. See, this is the node which is having incoming node as well as outgoing. outgoing branch, incoming branch, incoming branch, outgoing branch. So that is not the input node. Similarly, the output node number 2, which is important, is output node, right? So output node means the node where there will be only having the input node. That is why we have considered here another node x5 with a gain of 1, such that it is having only the incoming branch. If this is taken as the output node, so definitely that is also valid, but as we define the output node as the node where there is only the incoming node, but here branch, sorry, this A52 is the outgoing branches coming out of this branch node, so that is not considered to be the output node. So according to definition, so there must have be some another node x5, same node with a branch gain of 1, such that it is having the only incoming node, incoming branch, right? And next thing is that branch. Already I have discussed what is branch. Branch means this x2 to x3, this is a branch, x3 to x4, this is a branch, x4 to x4, this is a branch, x4 to x5, this is a branch. That means the signal route, that means the path through which the signal is passing, right? Number 4, forward path. As this is very much important because this is required here. You see, in the mission gain formula, when you will apply the mission gain formula to find out the gain, then the number of forward path is very much important. So once the number of forward path is important, that means you have to find out the forward path first. What is forward path? Forward path means the signal from input node to output node, the path through which the signal is passing from input node to output node without reversing the directions, without reversing direction, without reversing the direction. That is very much important. So that gives you the forward path, right? So that is why I am say for example from this structure, so what will be the forward path? So first of all, you have to find out which was input node. This is your input node, this is your output node. Now you have to identify the forward path. How? See, the signal is going through this path, arrow. Consider this arrow, this is arrow, this is arrow, this is arrow, this is arrow. So this is a forward path, this is a forward path, right? So what is the forward path here? Here forward path equal to, you can see it, x1 2, x2 2, x3 2, x4 2, x5. Isn't it? Is it a forward path? Is there any forward path? Yes, maybe there are different forward paths, so you have to find out. See, forward path means you have to move from input to output without changing the direction. So x1 to x2, no problem. So is this path will be available? No, as the signal is coming back. Is this path is available? No, as the signal is coming back. This signal path is not available, so you have to go to x3. So second path, forward path 1, I can say. Next, if possible, we will find the forward path 2. So x1 to x2 we have moved. So x2 to x3 we have moved. Now x3 to x4 if we move, and you see there is a path and you can move like this, right? So there could have been possibility, but the thing is that this is single node actually using twice. So once you have reached from x3 to x4, so x4 is used once, again from x4 to x4 you have used the node again. So this is the loop formed here, which will not give you the forward path, because without reversing the directions, because when you use the single node twice, so direction will be reversed. So this path is not cannot be considered. So this is not possible. So there is another path, say bypassing. So see the directions a35, so x5 via a35, right? That means this x1 to x2, x2 to x3, x3 to x5. without changing the notation and without traversing a single node twice. So that gives you the concept of forward path. So once this number of forward path for this particular section is 2, so you can get the number of forward path is equal to 2 for this particular example. If this number of forward path is equal to 2, so k will be 1 2 2, we can write, right? So number of forward path means 1 and 2. If the number of forward path is from 1 to 2, that means this can be written like summation of p1 delta 1 plus p2 and delta 2, as this is a summation block. So p1 delta 1, p2 delta 2. Now coming to the definition, this is the forward path we have already declared. Next path is path gain, p1. What is the p1 then? p1 is equal to forward path gain. So what is the path gain then? Path gain means once this moves from through any path, what are the branches it will cover? Say for example, forward path 1, this goes from x1 to x2 to x3 to x4 to x5. So what are the branches you have crossed? x1 x2 branch, x2 x3 branch, x3 x4 branch and x4 x5 branch, right? So what are the branch name? a12, a23, a34, a45. So this is the path gain for that forward path 1, right? So in order to move from input to output, there may be different forward paths, and once this forward path is achieved, that means there are different branches through which it has to move. So the branches means this branch gain will be multiplied. So p1 is the first forward path gain, p1 k is equal to 1, k is equal to 1 means first forward path, k is equal to 2 means second forward path. So first forward path gain is equal to, I can write a12, a23, a34, a45, right? So that is, this branch gains will give you the forward path gain. Similarly, p2 is the second forward path gain. This is your second forward path gain. So second forward path means this is x1 to x2, that is a1 to a23, a35, right? So second forward path gain you can obtain from here. Next comes so we have obtained t is the gain, that is equal to 1 by delta p1 delta 1 plus p2 delta 2 plus maybe p3 delta 3, maybe p4 delta 4, like this, depending on the number of forward paths. Once you get the number of forward paths, that means you will have the defined notations p1 delta 1, p2 delta 1, so on. So p1 we get the forward path gain, p means the forward path gain, right? So p we obtained, that means p1 already obtained. Now what is this delta? So in order to understand delta, I will write here, just remove this part, just remove it. So this part is very important to find out what is delta. So delta is defined as 1 minus sum of loop gains of all individual loops, plus means minus plus minus plus minus plus and so on, like this. But actually in practical system we can have up to the term third term, that is sum of loop gains of all possible combinations of two non-touching loops. The concept of two non-touching loop I will discuss, and that will be very much important. So two non-touching loops. Next part, sum of gain product. So gain product and gain product of all possible combinations of three non-touching loops. So first, the sum of loop gains of all individual loops. That means here the comes concept of loops. What is the definition of the loops, and why? What is the gain of the loop, right? So first of all we have to find out what is loop. So that is very important, and here from this signal flow graph we will find what are the different loops can be formed, right? So you see here sum of loop gains of all individual loops. That means what we have to find out, we have to find out first of all the number of loops possible. So loops are denoted by L1. We say L1 to dot dot dot, like L1, L2, L3 and so on. So first of all maybe individual loop L1. Loop means Loop means the branch or path that originates and terminates at the same point, right? That means this is say x1, this is say x2. That means the signal goes from x1 to x2 and from x2 to x1. So this is the loop without traversing a single loop, single node twice again, without traversing a single node twice. So that is the concept of loop. And say for example x1 to x2, this is a path. So having gain a1, x2 to x2, a1 gain a2. So what is the loop gain? Loop gains means this loop constitutes of two branches, x1 to x2 having gain a1 and x2 to x1 gain a2. So what is the loop gain L1? That is a1 into a2, like this. So this is the concept of loop and loop gain, and individual loop gains are considered as say for example L1, right? So how many loops you can find out here? Say loops means what is the concept of loop? You see from here x2 to x3 we are moving this direction without traversing these node ones, x4, and from there coming back to this, right? So this can be one loop, right? What can be the loop? This is one loop. What is the loop 1? That means you can say it x2 to x3 to x4 to x2 back. This is one loop. This is one loop with the loop gain. What is the loop gain? You can write the loop gain as this a23, a34, a42, a23 into a34 into a42. This is one loop. Similar, you see a x4 to x4. This is, you can say it as a2, loop 2 with gain a44. That is x4 to x4. That is a loop. Again, you can see if you can move from here x2. So x2 to x3 to x4. I can show you this is this x2 to x3 to x4 to x5 and back, right? So that can be loop 3. That is the way how you can have to find out the defined loops. Here the loops is x2 to x3 to x4 to x5 to x2. That means a23 into a34 into a45 into a52. So this is the loop gain L3. Another loop can be found out like say x2 to x3, then x5, and then coming back to x2. I show you this is the path where the signal is moving in the same directions without traversing its directions, coming back to this path. So L4 could be the next path, next loop. What is this? This is x2 to x3 to x5 to x2 back. That means the gain will be a23, a35, a5. These are the 4 loops I can find out, and then we have any other loop that you can have to find out. Maybe I can see this is one loop, this is one loop, and this is one loop, and this is one loop, right? This is one loop. These are the 4 loops I can find out from here, right? So these are all the individual loops. Is there any loop I can find out? Okay. No, I cannot find more than these loops here. So once you get the individual loops, then this part is finished. That means 1 minus sum of loop gains of all individual loops. So the delta can be now written like 1 minus L1 plus L2 plus L3 plus L4, right? So you see this L3 and L4. So this is up to this second term. Now sum of gain products of all possible combination of two non-touching loops. So that is very much important. Two non-touching loops. The concept of two non-touching loops. What is the concept of two non-touching loops? From the same figure, we can find out concept of two non-touching loops means that two loops, the loops which will not share common node. Very important term. That means they will not share the common node. For example, we have obtained the four loops. For example, we have considered this is L1, this is your L2, this is your L3, and this is your L4. These are the four loops we have found out. Now you have to just check the combinations L1, L2, but we have to check. You have to check L1, L2, L2, L3, and so on. So check L1, L2 combinations. Possible combination of two non-touching. Whether this L1, L2 will be non-touching combinations. L1, L2. See, this is L1 and one is L2. This is L2. See, this is the common node, right? L1, L1. This is L1 path, right? And this is your L2 path. So they are sharing common node. So this is not the possible combination of two non-touching loop. Next, L2, L3. This is your L2, and we are telling that this is your L2, L3 node. So this is passing through this. So L2, L3 is not possible combination of two non-touching loops. Similarly, what you have to do next is L1, L4. L1 is sorry, there is another loop we have missed. This is L5. See, the first basic loop I have missed. Sorry. So this is your L5. So actually there will be five individual loops. So L1, L4. That means combinations will be increased here. So L1, L4. So this is your L1, and L4 means this is your L4. So this is sharing this common node. So this will not be the combination. So L1, L2, L2, L3, L1, L4, L2, L4, L2. You see, this is your L2, and what is your L4? This is your L4. Fine. So this is your L4. L4 is having no connections with L2. So L2 and L4 will be one possible combinations. Again, check L1 and L5. L1 and L5. So L1 and L5 common node sharing, so it's not possible. L2 and L5. So L2 and L5. So they are not sharing the common node. So L2 and L5 will be possible combination of two non-touching loops. So 1, 2, 3, 4, 5, 6. So you get L2 and L5. This is a possible combination of two non-touching loop. L2 and L4 possible combination of two non-touching loop, and L2 and L3 is not. L1, L2 is not. L1, L4 is not possible. L1, L5 is not. L1, L4 is not, and L3, L4, L3. This is your L3 node, and this is your L4 node. So this is common. So L3, L4 is not possible combinations, right? So once you have found out the individual loops, then just check whether these two loops are in contact anyway or not. If there is no contact between these two loops, so no problem. Then that will be the combination of the two non-touching loops. Similarly, we check for three non-touching possible combinations: L1, L2, L3, L2, L3, L4, L1, L2, L5, and so on. Here, there is no such combinations where the three possible combinations of non-touching loops exist. So L1, L3, L5, for example, we are considering L1, L3, L5. This is your L1. Say this is your L3, and this is L5. They are touching. Okay, so by this you have to find out the possible combinations. What are the possible combinations you get now? So L2, L5 and L2, L4. So there is no possible combination of three non-touching loops. So we can modify this the delta. So what is the delta we are getting? So we will just remove all these things and focus on the mission gain formula. So T is equal to, we know, delta summation pk delta k. We know k is the number of forward path, already discussed. Delta is the 1 minus L1 plus L2 for the last problem. I will be having in your copy, plus two possible combinations L2 L4 plus L2 L5. That means the gain products are multiplied and there is no such combinations for three non-touching loops. So this is your delta, right? Now once you get the delta, so the denominator is obtained. K is equal to, for that particular problem we have discussed, is equal to 2 here. So T will be equal to 1 by delta. You just put the value of L1, L2, L3, L4, L5 and these products. So delta has been already calculated. Now this is your P1 delta 1 plus P2 delta 2. Okay, now once this P1 delta 1, P2 delta 2, that means P1 is already obtained, that is the path gain of the first forward path, P2 path gain of the second forward path. Now the things that what is the value of delta 1 and delta 2, right? So delta 1 is defined as that part of the delta for which that part of the delta that does not in touch with first forward path. Similarly, delta 2, that will be that part of the delta for which that does not in touch with the second forward path, right? So I am taking just a brief example, like say for example x1, x2, x3, x4. Right? So delta is defined is like this. Now see, we are having this kind of example. So for example, we are taking the signal flow graph is like this. This is your x4. So once you will move from x1 to x4, how many forward paths are there? x1, x2, x3, x4. One forward path. K is equal to 1, this, and x1, x4. So 2. So 2 forward paths. Now you see, there is one loop. This is loop 1. One loop. So there is no possible combinations, 2 possible combinations. So the delta will be, in this case there is 2 paths. So delta is equal to 1 minus loop gain, 1 minus loop gain, single loop, individual loop, and rest of the things, 2 possible combinations, 3 possible combinations are not there. So delta is equal to this. Now you have to find out delta 1. So when you will consider this delta 1, you have to consider the first forward path, right? So what is the first forward path? First forward path is this, right? This forward path, whether in touch with any loop or not, whether in any touch with any loop or not. So this first forward path is in touch with L1, is in touch. If touched, then that loop gain will be 0. So delta 1 will be 1. Understood? This forward path is in touch with loop 1. If there are 4 loops, L1, L2, L3, L4, and this first forward path is touched with all the loops, that means all the loop gains will be 0. So you just put this value and find out the value of delta. Similarly, here you see the second forward path. Second forward path is x2 and this. This is your second forward path. So is it is in touch with L1? No, not touched. Not touched means L1 will be having some value. So this delta 2, 1 minus L1. Got it? So to find out delta 1 and delta 2, what you have to find? You have to check the number of the forward paths. So if this forward path is moving in such a way such that it touches all the loops. If it touches all the loops, that means all the loop gains will be 0. L1, L2, L3, L4, L5, zeros. And if all these loop gains are zeros, individual loop gains are zeros, automatically their multiplications, combinations multiplications will be automatically 0. So you will be having delta 1 only. So if any forward path touches all the loops, that means this gives you delta 1. That is delta 1 for that is for that forward path is equal to 1. And if it does not touch with any loop, only that loop will be valid. For example, if in this case, this is the example we have already derived. So here you see, if the forward path, second forward path is in touch with L3, L4 and L5, right? If in case L3 touch 0, this is 0 and L5 0. So L3, L4 combinations, here L4 is there, so this will be automatically 0. And if L5 is 0, so this is automatically 0. So what you will be getting? So delta 2 will be 1 minus L1 plus L2. So this is the possible way to find out this delta 1 and delta 2. Once you get this, then this total gain of the system can be found out. Okay, so this is all about the signal flow graph, and in the next class we will discuss how to get the signal flow graph from corresponding block diagram of the system given, and if the signal flow graph is obtained, how to get the measurement gain formula. Okay, after going through this example, in the next class you will be a bit comfortable to find out the signal flow graph and gain of the system by using the measurement gain formula. Okay, thank you.